Right, so you all have a pen on your desk. Quick as you can, Oliver. Let's go, Brian. Right, so you've all got a pen on your desk. On your desk, in pairs or in ones, it doesn't matter, I don't care. I want you to have a look at the board, and I want you to think, what have we done over the last lesson or so that this brings to mind, okay? It could be absolutely anything, okay? So I want, and we're going to discuss it at the end, but I want you thinking outside the box. If it doesn't matter how silly it is, you make sure you write it down, okay? Quick as you can, ladies, please. Okay, so has everybody got a pen? Books on the ground, please. So nobody looking at their book. You have now, Mara listening up, please. You have now got 3 minutes to write as much on your desk, and if you run out of space, you can come and write it on the boards, as much as you think you can write about everything on that board. Please don't think too big. It could be anything. Okay? No looking in your books though. As quick as you can. So Jack, pop in your pen, get your pen ready, please.
We write on the table?
Yep, on the table, please. Working with your neighbour. If you're worried about something, ask them. Would this be relevant to put down? Would this be okay to put down? But remember, nothing is wrong. Talk to each other. If you're nervous, ask.
I don't know if this case I don't know.
Okay, so we've got about a minute left. Yongji, anything. Anything at all. It might be that what you've written down is slightly incorrect. I don't care. Whatever, because we can deal with misconceptions then. You write down anything that you see. Anything that we've worked on. I love it. Kenneth is turning into the working out king. He's gone from being just a number as an answer to now he's doing everything that I've asked. Well done. Brilliant. Okay, there's lots of pictures which I like. Some people have got lists. Okay, 30 seconds. Doesn't matter. I told you, nothing's wrong. Apart from the fact that my board's gone off. That might be wrong. Right, as soon as I get the board up and running, we are off. Is anybody missing for the register?
Probably me.
Anybody missing? Who's missing?
Oh.
Nobody's missing. Okay. Okay. Right, okay. What you are going to do now is one of you in your pair is good. You've got 3 boards. This one, and this one. If you go to the middle board, please do not take the end of the pen off. Okay, otherwise I might get in trouble. Okay, so whichever board you want to go to, I want one of you from each table, one of you in each pair, to come up and write something on the board that you've got on your desk. Okay, so nominate which one. All of those people come up, space yourselves out. Yeah, go for it, Delilah. Don't be nervous. Go and write something on one of the boards.
And Jack, x plus c. And x plus c. And x. Yeah. And Jack.
Try and look. If somebody's already written what you've done, then try something else. Right, once they get back, the second person, just take a look at what's already been written and then go up and write something yourselves. You can go try. Do you know what you're going to put as a second thing? Good.
Equals change.
But I don't know if this is correct.
Wait,
I'm
this.
just guessing.
This.
So, right, Kenny, do you want to go and change it? Go and change it.
Wait, which
I
one?
did I mess that up?
Oh yeah.
The other way around.
Oh wait.
It is.
Other way around.
I totally got it.
Changing Y over changing
Okay,
X.
right.
Yeah.
Jack, I was right.
You were right.
It was changing y over changing x.
Yeah. Don't change it unless you have that discussion. Be proud of yourself. Know what you're doing.
I agree.
Okay, brilliant. Okay.
Love it.
Oh, I love that. Yes. I was just thinking, oh, well, everybody's done that, but no, nobody did that. Well done, Chloe. Brilliant job. Okay, so we talked about. I'm just gonna ask some questions. We've talked about this. A couple of people talked about this. What is this?
Pythagoras theorem.
Pythagoras theorem. Why did you put it up there when it was straight line graphs? What was the reason, Amara?
Right angle triangles.
Right. Okay. Why? Where is the link with right angle triangles? Somebody else. Jago. The dot things. What are the dot things? Help absolutely. What are the dot things, Chloe?
Oh, not like the dot things like make a triangle, like a right angle triangle that show like the gradient.
Okay.
But also on the board you have like we have a triangle that says x 8 and 15 and if we're looking at x we use Pythagoras.
Okay. So absolutely. So if we does anyone know what the x is called? Somebody. Hypotenuse. Good. Who's that? Well done. Delilah, well done. It's the hypotenuse. Now, can you tell me why I might have put a right angle triangle, and someone's already said, because we draw a right angle triangle on the slope, on the straight line graph. Okay, but can somebody tell me what's the reason? What can we, how am I trying to express myself here? Okay, what could we use Pythagoras for then, as well as the gradient? What could it also help us find, Maddie?
The missing sides.
The missing sides in terms of what?
Like the missing gradient.
The missing gradient, no, but I like the fact that you're putting it into that. You like? Right, would Pythagoras find missing angles? Right, what would we have to link in? Trig, yeah, trigonometry. If we're thinking about angles, it would be trigonometry. Okay, Amara?
To find the gradient.
No, we won't use Pythagoras. Well, we could, but we'd use division rather than Pythagoras' theorem. Chloe, one last thing.
Maybe when we're trying to make the triangle on the slope, we have the two sides that we already know and then put like the actual slope.
Okay.
So that we don't know, therefore we would use Pythagoras.
We can find, okay. So I'm gonna link into that later on, and you will know from what we've talked about, you'll go, starter. That's why the old bag put that on. Okay, so love the fact that we've got positive and negative gradients. Okay, which one was a positive gradient? Which one was a negative gradient? Yeah, Jack. The first one's negative. The second one is positive. Good. Okay. I put two dots on here. Did anybody read react to the two dots? Maddie, what did you talk about with the two dots?
It's,
You
you find the gradient.
find the gradient between those two dots. Why wouldn't I do this then? Oops, easy tiger. Okay, why wouldn't I do this and this as my two dots? Kenny?
Gotta get the integer.
We've got to get, yeah, I agree. Can somebody make it a little bit more? Olivia. Oliver, there you go. Oliver, are you going to join in with us? Why wouldn't I put the points there and there? And Kenneth has just said, because we need to work with integers. What does he mean by that? I'm a little bit confused. Any ideas?
It has to be a number that doesn't have a decimal.
Good. It has to be a, would we use number? What are we using at these points? What are they called? Yeah, brilliant. It's got to be a coordinate where we're not looking for a decimal. Okay, Chloe, sorry.
I was gonna say full coordinate.
Yeah, a full coordinate. And we talked about that, where each x and y coordinate is an integer, going back to Candice's idea. Okay, so if I am having a look at this then, you've all got changing y, changing x. Okay, can you put your pens down, please? And can we now get our books up, please? You can rub it out if you want to. No, easy, Tiger. Here, look. If you need some squidgy, there you go.
Jackson, squishy stuff.
Squidgy. Don't worry if it's a little bit, I will deal with it at the end.
Other stuff.
Look, we're so worried about it, don't worry. It's fine.
I'm just worried about it.
Okay. Thank you, Delilah. You are the chief squidger. Yes. Kenny, I'm going to have to hurt you in a second. Okay. So books open, straight line graph is our heading.
That's mine.
Straight line graph is our heading. Maddie. Okay, so straight line graph. Okay, so something we haven't spoken about is that general formula, which I know a few of you had on your desks. Can somebody remind me of the general formula of a straight line graph, Mario? Mx plus c. From last lesson, can you remind me, we did a little bit on some of these. Can somebody remind me what any of it means? Y equals mx plus c. Can anybody remind me? Pi, can you remind me of anything that y equals mx plus c might have been? The y is the y, I like that. Okay. What else have we got there? I love it. Kenny.
M is the gradient and C is the constant. The X.
Okay, so M is the gradient. And what did we say the gradient was, Maddie? What was the gradient? What was the formula for the gradient? Was it y over x?
Yes.
Were we just looking at y over x? Be careful, Jack, think. Listen to what Maddie said. She said m equals y over x. You're thinking that's correct? Can somebody give him a hint? Maddie and Jack, you're listening for the hint. Don't give them the answer, give them a hint. Who's got a hint for them? Delilah. That's not a hint. Okay. Okay, Jack, back to you, or Maddie, back to you. Can somebody tell, can either of you tell me, is it just y over x? No, definitely not x over y. Yum yum. Kenny, yum yum.
Change.
Change in y over change in x. So change in y over change in x. Okay, brilliant. Be careful, making sure that you acknowledge it. Because what we're doing is going from one coordinate to another. Okay, so we need that change. Okay, brilliant. What did now, Kenneth, I think you said this was the constant. Okay, we talked about the constant. What was this one then? If this was a constant, what was the mx?
The m was a coefficient of x.
I like it, the m is a coefficient of x. But is that constant? Is that a constant? Why no? Someone's saying no, but I don't. Amara?
Because the x is the number. Because if you look at the table, there's x and a y. There can be, you can choose whatever x you like, and then below you'll do the equation for y.
Okay, so your x can change, therefore it's variable. Your y will change as a reaction to what your x goes into. Okay, the c is a constant. What did we talk about? We only talked about it a little bit. Brian, what did we talk about with the c? Where did we see that on our graph? The y-intercept. Good lad, well done. So that was the y-intercept. Okay. Absolutely brilliant. Well done. Can somebody tell me, just out of interest, what the gradient of this would be? What is the gradient of that? Has anybody just got me an answer? What is the gradient of this one here? Jago? You think 1.5. Okay, so Jago thinks the gradient here is 1.5. Can somebody verify that? Can someone check that? Tell me it's correct? Or you think it's 1.5 as well? Okay, you're going to have to help me because I have no idea where you got that from, Amara.
6.
You got 6. So you got a gradient of 6. So Amara's with me. She's like, I don't know where that came from.
I got that too.
You got what? 6. Okay. Right, Amara, can you tell me where you got 6 from, please? And then Jago will ask you where you got.
Equals in change with y and in change x as well. So you would put the y above the x, which is 7 over 1. And since it's in change, that would be
Now, Amara, oh, out of the corner of my eye, my peripheral vision, I can see Jago going. So, Jago, do you want to explain?
Y is 6, like going up 6.
Right, okay, do you want to explain a little bit more? Why is it 7? Right, 1 minus 7. So we are starting on the y-axis at 1, and we are going up to 7. That is my, when I pick those two whole coordinates, that is what my change in y is. And you're talking brilliantly, Amara, about that change in y, okay? So this is the change in y from 1 to 7. Are you happy with that? So the coordinate here is 0, 1, and the coordinate here is, 4, 7. And you can see my y went up from 1, because it's x and y, went from 1 to 7. Are you okay with that? Back to you, carry on. Okay, how have you got 4? Oh no, how has he got 4? Yeah, so it starts at 0, doesn't it? And goes to 4. Brilliant, so what did you do then? Then it's 6 over 4. Right, so 6 over 4. What's that, ladies? Talk to us. No, please, talk to us, it doesn't matter.
It just said that you got 1.5 instead of 6. I was asking if you understood.
Okay, so what would you do to 6 over 4? Maddie?
I thought it was 6 over 4 is going to simplify to 3 over 2.
Love it.
Equal to 1.
and therefore is equal to 1.5. Are you happy with that? Yeah? Brilliant. Okay, thank you very much, Diego. Amazing. Are you okay with that? Okay, Amara, I'm going to pick 2 coordinates. Can you just very quickly tell me what's the change in y? The answer's 2, okay. So your gradient is 2, why?
Because 4 over 2. Because
Okay.
that side's 4 and the bottom side's 2, so.
So Amara's running around and she's like, yes! I've got it right. Pear's got her hand up. Sorry, Amara, something's gone wrong. Pear, what's gone wrong? It is a negative gradient. It is going the other way. So it is going from top left to bottom right. So in which case, negative. Now, what you could think, Amara, you could look at that and go to negative gradient. Or you could think, I'm going down 4 to then go right 2.
I wonder if you could this doesn't go with the y side, but could you go with the opposite direction?
Absolutely right. Okay, brilliant, brilliant. I love it. Let's go with a different colour. Let's go with pink. Amara's sitting there going, I want to go in the opposite direction. What's the change in y, Amara?
2.
That is still the y. Remember, the y is vertical. So whether you do the right angle triangle on the underneath or above, I don't mind, but don't then change where your x and y is. Remember, the x-axis is across, so the change in x will be the difference across. Are you comfortable with that?
Yeah.
Brilliant. Okay, thank you. Thanks for that. And at some stage, we will look at why the hell I've got Pythagoras on the board. Okay, really impressed with what you've come through. Now, have a look at this. You have got 30 seconds to tell me what is the gradient of each line. So all I want you to do is write the number. What is the gradient of each line? That 30 seconds starts now. Come on, Yong, you need to get yourself started. Don't give anybody else the answers, okay? Yong, just for you, I'll start for 30 seconds again. There we go, it's starting now, as quick as you can. Kenneth, have you finished?
Yeah.
This is your whole delight, isn't it? Just the number, no working this. So the gradient of every single one of them. So Nata, I'm coming to you because you're looking confused. What do you think the gradient of A is? Okay, right, Nata, I'm going to ask you B in a second. Watch what somebody gives me. Brian, what is the gradient of A? 3. Nata, what's the gradient of B? 2. Perfect. Yong, what's the gradient of C?
7.
Brilliant. Let's do June. What's the gradient of D? 10. Brilliant. Someone used this word earlier, and I think it was Chloe. Can somebody tell me a word that would describe where we're looking for the gradient when we've got a general formula? Can it?
And the one in front of the X.
Okay, someone had a real good Nata. Good, the coefficient of x, which is exactly what you're saying. The number in front of the x, which is being multiplied by the x. Okay, brilliant, brilliant. So therefore, is Jack, E, what's the, that's, no, what's the correct one? Why is it 1?
Because X equals 1.
Well, it's,
No, it's 1 times X.
yeah, it's absolutely good. Be careful about the x equals 1 because we just talked about that being a variable, yeah? Delilah, F, what's the gradient? 6. Okay, J, nobody's going to be able to do J. Pi, it's landing on you. J, what's the gradient? Absolutely perfect. It can be a fraction. Well done. You were nervous, you came through it. Okay, so positive, negative gradient. How could we have made this harder? Yeah.
What was I and J again?
I was an Anybody help? What's I, Chloe?
Half.
Good, the gradient is a half, because the half is the coefficient of x. Okay, and J was -4/5. Okay? Thank you for asking. Right. How could I have made this harder? What could I have done to make it a little bit more difficult for people to go, oh, the gradient is, Maddie, what? You can rearrange, okay, so what could you do? Give me an equation. 1 plus y equals 3x. Okay? So you heard Maddie say you could rearrange. What does Maddie, stay quiet a second. What does Maddie mean about that? What would we have to rearrange it to? Mario?
Well, you don't have to.
We do. Well, I guess we don't, the gradient, but we do pair. What do we have to rearrange it to? To equal y. And when we did changing the subject, what did we call that? Yeah.
Making the subject one.
Yeah, making y the subject, leaving it on its own. Okay, can somebody tell me what we would have to do to make y the subject? Chloe?
You would take a constant and move it in front of the y, and then if it was a plus, it would become a minus multiplication.
In front of the y, it's already in front of the y.
No, like if it was like a normal equation, like if it was y equals 1 plus 3x, you would move the 1.
Okay, so you're hearing her and she's actually on the right lines. Can anybody neaten that up a bit? Kenny?
Or do the opposite operation.
Good, okay, so what,
Other side of the thing.
okay, so what would it look like?
It's gonna look like 3x minus 1.
Good, so we would have y equals 3x minus 1. So you're not always, and then we can see that our gradient is 3. And our y-intercept is what? -1, good. Okay, you have to make it, the general formula is y equals mx plus c. We can pull the gradient off when we've got the coefficient of x, but only when it's y equals. Okay? Okay. I'm just going to skip those a second. We're going to look at that in a bit. But what you are going to do, I'm going to give you a sheet of paper, because I've spoken enough for a minute. I'm going to give you a sheet of paper. It's got gradients on the top. On the back of it, it's got fractional gradients. I want you to find the gradient of each. Think about everything we've talked about. You do not have to do, but bearing in mind, some of you had forgotten it was changing y or changing x. You do not have to write that on the sheet. I just want it to be a speed practice at the moment. We've got enough of that in our books, I guess. Okay, so very quickly, can you find the gradients of each of these lines? Does it matter, one last question before I do shut up. One last question. Does it matter how big my right angle triangle is?
No.
No, but what does it matter?
Has to be a full coordinate.
Good, it has to be a full coordinate. What will happen if you make your right angle triangle too big? What will you have to do with your answer? You'd have to simplify it. Good, Jago. Okay, Amara, what are you going to be careful of?
Negative and positive.
Yeah, checking whether it's positive or negative, yeah? Okay, you have 5 minutes, guys. Draw your right angles on there. Sorry, say that again.
Oh no.